Hello guys, welcome to another episode. In this video, we're going to be discussing about relations and functions. So before going into relations and functions, the main and most important thing which you know is Cartesian product of two sets. And to know Cartesian product of two sets, you should be knowing how set theory works. So if you don't know how set theory works, I'll put the video link in the description. If you know about sets, so let's start with the Cartesian product of sets. So let's begin with the definition. So if I say A cross B, which means set of all x such that set of all ordered pair x comma y such that x belongs to A and y belongs to B. So this is the basic definition of Cartesian product of two sets. So you know, now to understand this, let us use an example to understand this better. Imagine your set is Andhra Pradesh, Karnataka, Kerala. So I'll use an example of how the departments in the RTO office they make number plates. So Andhra Pradesh, Karnataka, Kerala I think Kerala, Delhi, Madhya Pradesh, etc. Imagine these are the 5 different states. So and then set B is 01, 02, 03, 04. Now if I say A cross B, which means I have to first take first element from A and then multiply with everything which is there in B. So first AP comma 01, and you're going to enclose this in 2 brackets. So like just like this, just like how you frame the coordinates in 2D plane, like you have this 2D plane, right, x axis, y axis, and you have a point here and then it's 3 comma 2. In the exact same way you write the order pair like this, and while doing the order pair you're gonna go to the first set. So if I say A cross B, go to the first set and then match with every single element which is there in B. So AP comma 01 comma AP comma 02 AP comma 03 AP comma 04. So after you're done with AP, let's go to the next one, KA. So KA 01 and then KA 02 KA comma 02 KA comma 03 comma 03 KA comma 04. In the exact same way you can do for Kerala also. So KL 01 all the way up to KL 04. In the exact same way I can do for Delhi also. So I'll just write so on so on. And the last one MP 01 MP 01 MP 02 MP 02 and all the way up to so MP 03 MP 04. So MP 04. So this is Cartesian product of two sets. So basically you're trying to multiply and create ordered pairs like this, and the first element in the ordered pair will be belonging to first set, and the second element will be belonging to second set. So that's the definition. If A cross B equal to set x comma y such that x, so this x should be belonging to A, so x belongs to A, and this second element y should be belonging to B. So suppose if they ask B cross A, if they ask B cross A, you should do the exact reverse. So B cross A is equal to set of all x comma y such that x belongs to B. Remember always the first set belongs to the first element and the second set belongs to the next pair. So that's how it is. So y belongs to A. It's like ordered. This should always go to the first one and this should always go to the second one. So if you do B cross A in this example, so in this example we have to take this element and multiply to the every single one. I hope you're getting this. So 01 comma AP and then 01 comma KA 01 comma KA 01 comma KL 01 comma KL 01 comma DL 01 comma DL 01 comma MP. So in the exact same way you can keep doing this for every single element. Say for example the next one is 02 comma AP, so 02 comma 02 comma AP, and next one 02 comma KA 02 comma KA, so on 02 comma MP, and then take the next element 03 and then multiply in the same way, and then take 04 and then multiply in the same way. So on 04 AP and all the way up to 0, 4 empty. Try doing this. Try filling filling all the missing elements. So one thing you observed here is your A cross B was not equal to B cross A. Now most of the time these two are not equal because the ordered pair matters. For example, you have a graph, and there's a point here which is 3 comma 2. So 3 comma 2 ordered pair is completely different from 2 comma 3. So you have one more ordered pair, suppose it is 2 comma 3. So these two ordered pair are not equal because they represent different points on the plane. In the exact same way, if you flip the, like suppose we did a cross b, we got some set of elements. We did b cross a, we got different set of elements. Now those two are not always equal. Most of the time they're not equal. In this case, they're not equal. So always remember, a cross b is not always equal to b cross a. So this was a basic introduction of Cartesian product of two sets. Now let us discuss some important notes which you need to notice in this theory. So so some of the notes which you need to notice is, if two ordered pairs are equal, which means every single corresponding elements are equal. For example, suppose you have x comma y equal to a comma b, which means every single element is correspondingly equal, just like how we do in graphs. Like say if I say x comma y equal to 2 comma 3, if I say this, which means x equal to 2 and y equal to 3, isn't it? In the exact same way, x equal to a and y equal to b. We're going to face a lot of problems, math problems on this topic, so kindly note this. So one more thing you need to notice, suppose the number of elements in set A is equals to m and number of elements in set B equals to n. So number of elements in set A equal to m, number of elements in set B equal to n. The number of elements in A cross B is going to be number of elements in A into number of elements in B. Say for example, your A equal to 1, 2, 3, 4, 5 and your B equal to A, B, C. So what is the number of elements in set A? So number of elements in set A is 5 elements. Number of elements in set B is 3. So substitute here. I can do it like this: m into n, 5 into 3, which is 15 elements. So if you do A cross B, you're going to get 15 different elements. You can verify this. So 1 comma A, 1 comma B, 1 comma C. So you have 3, and then 1 comma A, sorry, 2 comma A, 2 comma B, 2 comma C, 3 comma A, 3 comma B, 3 comma C, 4 comma A, 4 comma B, 4 comma C, 5 comma A, 5 comma B, 5 comma C. So totally you will get 15 different elements. So you can, instead of doing the multiplication every single time, you can directly go to this formula and then apply this to find the number of elements of A cross B. And the next thing you should note is, if you have R cross R, so R is set of all real numbers and you are multiplying with set of all real numbers. If you don't know what real numbers is set of all rational plus irrational numbers. So if you unite rational and irrational numbers, you get all real numbers. It's basically all the numbers, just basically every number on the number line. So you have this real number line, x-axis, y-axis, right? So every single number which you can represent on this number line are real numbers. So if you take those two elements or those two sets and try to multiply them, you're going to get x comma y, where x belongs to R and y also belongs to R. So this represents all the points in the plane. So since you're taking two ordered pair, so this is basically ordered pair. So all the points what do you get here? It's like every single point what you get, every single one of them represents a point in the plane. So you need to remember that every single point from this Cartesian product represents point in the plane. So this is x-axis, y-axis. So that's the one thing. And the next thing is, if you do R cross R, which is basically x comma y comma z, where x belongs to R, y belongs to R, and z also belongs to R. So this is basically all the points in the space. So if you, like, what are the possibilities, what are the possible outcomes what you get? Every single outcome represents point in space. So 3D space, you guys probably know this. So this is x-axis, y-axis, and this is z-axis. So if you find all the numbers here, the numbers are going to represent all the points in the space. Now if you're wondering how we could do triple Cartesian product, it's just basically you're going to take, for example, say A equal to 1, 2. So if you do A cross A, so basically you're going to create one more A, and then multiply with that. So 1 into 1, so 1 comma 1, and then 1 comma 2, and then you have that, then 2 comma 1, 2 comma 1, and then 2 comma 2, 2 comma 2. So after doing this, just multiply it with a once again. So just multiply with a once again. So take one more a, which is 1 2, and then multiply this. So a cross a into a. So here what you get is triple order pair. So 1 comma 1 into 1. So this is basically 1 comma 1 is from this into 1. So this is comma 1. So 1 comma 1 into 2. So 1 comma 1 comma 2. And then next is this into this. So 1 comma 2 comma 1, 1 comma 2 comma 2. And then this into this. 2 comma 1 comma 1, 2 comma 1 comma 2. This into this. 2 comma 2 comma 1, 2 comma 2 comma 2. So this is the triple ordered pair. So if you do this for real numbers, you're going to get all the possible points in the 3D space. So let us now try to solve some problems. And the textbook I'll be using here is Ncert textbook from 11th standard mathematics. I'll put the textbook link in the description. You can go and download it for free. I'll be solving some example problems. You can go and try the exercise problems. So let's get started. So the first example is if x plus 1 comma y minus 2 equal to 3 comma 1, we are supposed to find the value of x and y. As I told you before, if two ordered pairs are equal, which means every single elements within them are also equal. So x plus 1 should be equal to 3. So x plus 1 should be equal to 3, and y minus 2 should be equal to 1. Y minus 2 should be equal to 1. Always remember, if two ordered pairs are equal, their corresponding elements like this will be equal to this, and this will be equal to next one. So we got this equation from that, and then let's try to solve this. So x equal to 2 and y equal to 3. So the next one is if a equal to abc and q equal to r, we're supposed to find p cross q and q cross p. So first is p equal to a, b, c, and q equal to r. So basically multiply this with this. So p cross q is going to be a comma r, and this with this, b comma r, and this with this, c comma r. And next we have q cross p. So q r p equal to a, b, c. So in this case, q cross p is going to be q into, so r into a, r comma b, r comma c. So as you can see from here, this is not equal to this. They're not exactly equal, right? They should be exactly like copy paste. Then only we can say two ordered pairs are equal. So here you can see p cross q is not equal to q cross p. So we can verify using this example also. So the next problem we have a equal to 1 2 3, b equal to 3 4, c equal to 4 5 6. Find a cross b intersection c. So let's solve the first one, which is a cross b intersection c. Let us first find what is b intersection c is. So b intersection c, b intersection c. So you have to see all the common elements. So what are the common elements? 4. So 4. So basically we have to do a. So a equal to 1 2 3, and then we have to multiply with this. So 1 comma 4, 1 comma 4, 2 comma 4, 2 comma 4, 3 comma 4, 3 comma 4. So next one is, so that's the first one. Second one, we're supposed to find a cross b union c. So let's first find b union c. So we have to merge these two sets, which means 3 4 5 6, and then we have to take a, which is 1 2 3, and then multiply everything with this. So 1 comma 3, the first element. So 1 comma 3, 1 comma 4, 1 comma 4, 1 comma 5, 1 comma 5, 1 comma 6, 1 comma 6, and then you have 2 comma 3, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, and then you have 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. So this is the answer for the second one. Let's try to solve the third one now. So we have a cross b intersection a cross c. Let's find first a cross b and a cross c. So a cross b, so you have to cross these two. So 1 comma 3, 1 comma 3, 1 comma 4, 1 comma 4, 2 comma 3, 2 comma 4, 3 comma 3, 3 comma 3, 3 comma 4. And the next one is we have to do A cross C. So these two sets we have to cross them. So A cross C. So 1 comma 4, 1 comma 4, 1 comma 5, 1 comma 5, 1 comma 6, and then you have 2 comma 4, 2 comma 4, 2 comma 5, 2 comma 6, and then you have 3 comma 4, 3 comma 5, and then 3 comma 6. So then what are they asking? We have to take common elements between these two. So they're asking A comma B intersection A comma C. So see what are the common elements between these two sets. So what are the common elements? 1 comma 4 is common. Then what else? 2 comma 4 is common. 3 comma 4 is common. So this listed over here. So 1 comma 4, 2 comma 4, 3 comma 4. And the last one is we have to do the union of these two sets. So just merge these two sets, we'll get the answer. I'm not going to do that. Try this. So that was the example 3. Now let's move on to the example 4. So the next one is if p equal to 1 comma 2, find p cross p cross p. I suggest you to try this. So if you know how to solve this, pause the video and solve this and then compare with my answers. So p equal to 1 comma 2. So let's first find p cross p, which is 2 product of 2 Cartesian planes, Cartesian sets. So 1 comma 1, 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 1, and then you have 2 comma 2. So this is the first, and then you have p cross p cross p. This is what you're supposed to find. So we have this, and then take another p and just multiply this. So take another p, 1 comma 2. So that's equal to, so this into this, 1 comma 1 comma 1, then this into this, 1 comma 1 comma 2. Next this into first element, 1 comma 2 comma 1. So this into this second element, 1 comma 2 comma 2. Similarly this into this and this into that. So 2 comma 1 comma 1, 2 comma 2 comma 2, and then last, so 2 comma 2 comma 2 comma 1, and then 2 comma 2 comma 2. Hello guys, welcome to another episode of Relations and Functions. In this video we're going to be discussing about relations. So if you know how Cartesian product of two set works, let's get started. Behind me I have two sets, P and Q. P is set of P is equal to ABC, Q is equal to Ali, Bhanu, Binoy, Chandra, Divya. So we're going to use this example to explain how relations works. So let us try to form P cross Q. P cross Q, which means it goes like this. So A into Ali, A into Banu, so A Banu, and so on. A Divya. Next B Ali, B Banu, so on. B Divya. And the next last one is C Ali, C Banu, so on all the way up to C Divya. Now I'm going to define a statement. I'm going to define a set. So suppose the set name I'm going to call it as R, and I'm going to say that the first letter in the, so suppose I'll write set of all x comma y such that x is the first letter of y. First letter of y. So basically we're supposed to find the elements in which this, whatever the x we have, it should be the first letter of y. For example, B Banu, so that like that, and A Ali. So we need to categorize those in one single set, and we're gonna call that as R. So what are all the elements which you can put in this set? So this you can put A Ali, because see, so the set says x is the first letter of y, is A is the first letter of this y, so this is x, this is y. So basically x should be the first letter of y. So A is the first letter of Ali. So we're supposed to find these kind of elements. So next thing which we can choose here is B Banu. We can choose B Banu, and then B Binoy. B Binoy. Try to solve this on your own. And then what else we can choose? You can choose C Chandra. C Chandra. I think these are all the elements possible here. Now basically what we done here is relation. What we found here was basically relation. So you're going to find the relationship between these two. You're going to frame as a relation and then list all those elements. So a relation is basically a subset of Cartesian product of two sets in which the elements are related to each other. So how these elements related to each other? So this is the first letter of this word. So basically a relation is a subset derived by describing relationship between first element and second element of the ordered pair p cross q. That's what basically we did. So we described p cross q, we got all the elements, we set up a relationship between first element and the second element like we did here. So x is the first letter of y. See, we established a relationship, and then all the elements which you got from here was basically a subset from the set of p cross q. So this was basically how a relation works. Now the next thing which you need to know is domain, range, and codomain. So please pay closer attention because people normally make mistakes in this. So domain is set of all elements in the ordered, so set of all first elements in the ordered pair of R. So you have this ordered pair of R. So you just have to basically list a set in which contain all the first elements of R in the ordered pair. So your domain in this case it's going to be A, B, C. So A, B, C. We have B two times. We're going to write only one time because number of time doesn't matter. Just have to write it once in sets. And the next thing is range. Set of all second element in the ordered pair of R. So you just have to list the second element in the ordered pair. That's your range. So that's all. So you have Ali, Banu, Binoy, and Chandra. And the codomain is going to be, so codomain is the whole set Q is codomain. So you do your P cross Q. So the next set Q, the whole set is basically codomain. So that was the basic definition of relations, domain, range, and codomain. The next thing which you need to know is arrow diagrams. So arrow diagrams is just like Venn diagrams. So Venn diagrams is used to visualize the sets. In the exact same way, arrow diagrams is used to visualize relations. So in this example, we have relation is framed as set of all x comma y such that x is the first letter of y. So we write the set which you're going to define the relation like this. So P we wrote like this in a circle and list all the elements inside the circle, and we have Q and then write the same thing and then list all the elements inside the circle. And the next thing is based on the criteria which they give, we're going to match those. So our criteria is x is the first letter of y, which means just like what we got here, we're going to match like that. So this matches with this matches with these two, and this matches with this, and we just listed everything. But also you could have done this also, which is again correct. So either in this way or in this way you can visualize relations. So this was arrow diagrams, which is a very good way of visualizing relations between two sets. Now we're going to solve some problems, and the textbook will be, which I'll be using here is Ncert textbook of 11th standard. I'll put the textbook link in the description. You can go and download it for free. Now let's get started with the problems. So the problem is, let A equal to 1 2 3 4 5 6 define relation R from A to A by R equal to set of all x comma y such that y equal to x plus 1. In this we're supposed to solve, we're supposed to represent relation in the arrow diagram, and we're supposed to find domain, range, and codomain of R. So let us try to solve the first one, which is finding the relation and then representing it in the form of arrow diagrams. So what I'm trying to explain, so the relation is framed like this: x comma y such that y equal to x plus 1. So basically your second number or the second ordered pair like this should be one more than this. For example, this is 1, which means this 2. So this should be one more than this. Or for example, if I say 2, this should be 3. If I say 3, this should be 4. So it's like that. So from your ordered pair, what you have, so your given set is A equal to 1 2 3 4 5 6. So it should not basically exceed what numbers it's therein with you. So A to A means you're going to basically pick up all the elements from A and A. So this is your 1A and this is your another A. So which is 1 2 3 4 5 6. So let us try to write the relation in the form of Russo form. So R equal to 1 comma 2 2 comma 3, and then what I can do, 4 comma 5, and then I can write 5 comma 6. Can I write 6 comma 7? 6 comma 7? No, I can't write 6 comma 7 because 7 is not there in this set. So this is not there. So this is cancelled out. So this was our relation. Now we are supposed to represent this in the arrow diagram. So this is our A equal to 1, 2, 3, 4, 5, 6. Since we're trying to find the relation from A to A, so one more set is also going to be our A itself. So 1, 2, 3, 4, 5, 6. Now we are supposed to match. So 1 is related to 2. So 1 is related to 2. Next 2 is related to 3, 2 is related to 3, 3 is related to 4, 4 is related to 5, 5 is related to 6. So this is the arrow diagram of this particular relation. The next what they're asking is domain, codomain and range. Let us first find domain and range. So domain, as I told you, is the first element of the ordered pair in the relation. So 1, 2, 3, 4, 5. So my domain is going to be 1, 2, 3, 4, 5. My codomain is going to, sorry, let us first find the range, domain and range. My range is going to be the second elements of the ordered pair in the relation. So 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. My codomain is going to be my second set. Codomain. If you're having difficulty of how to find codomain, so just basically have to see. So we are taking A cross R, A cross A, right? So this second set is always going to be your codomain, always. So this is our codomain, which is basically A itself in this case. So our answer is A. So this is how you find the relation, and this is how we represent relation in arrow diagrams, and this is how we find domain, range, and codomain. It's very easy. People don't normally get it, but it's very easy. So let us try to solve one more problem on this. So the next problem is the figure shows relation between P and Q. Write the relation in Rooster form, set builder form. Also find the domain and range. So it's given in the question like this. So PQ. So 9 is related to 3 and minus 3. 4 is related to 2 and minus 2. So you can see the thing. 4 is related to 2 and minus 2. 25 is related to 5 and minus 5. You might be seeing some relationship right now, but let us try to write the relation in Rooster form first. So R equal to 9 comma 3, 9 comma minus 3, 4 comma 2, 4 comma minus 2, and then 25 comma 5, 25 comma 5, 25 comma minus 5, 25 comma minus 5. So if you want to write this relation in terms of set builder form, it's going to appear something like this. So R relation equal to set of all x comma y such that y is the square of x. Y is the square of x, isn't it? See, if you square y, you're going to get x. So square y, 3 square is 9, minus 3 square is 9, 2 square is 4, minus 2 square is 4, 5 square is 25, minus 5 square is 25. So you can write the relation in like this. So just try to observe the pattern between the numbers and establish a relationship like that. So next thing which I'm asking is find the domain and range. As I told you, domain is all the first element in the ordered pair of relation. So 9, 4, 25 is your domain. So domain equal to 9, 4, 25, and your range is going to be set of all second elements in the relation. So range equal to 3, minus 3, 2, minus 2, 5, minus 5. What if they ask codomain? All the elements which are there in this set, it's basically a codomain. Hello guys, welcome to the third episode of Relations and Functions. In this video, we're going to be discussing about functions. So what exactly is a function? Let us try to understand this using this example. Imagine you have a machine. So this machine, imagine this is a sugarcane juice making machine. Okay. So for every single input you give, it gives a specific output. So this machine, so if you put suppose sugarcane inside this machine, you get sugarcane juice outside. So in the exact same way, function is also a type of machine. So we give a special input in the form of numbers. This function processes those inputs and produces a specific output. So output. So what are all the possible input which you can give? Those inputs are called domain. So what are the possible inputs you can give to this function is called domain. And what are all the possible outputs you can get from the function by processing it? We call it as range. So I hope you have an idea of this. For example, if we take f of x as imagine we define f of x as x square. So if I put x equal to 1, so let us try to process that function. So f of x equal to x square. So if I put x equal to 1, f of 1 square equal to 1. So my output I got it as, f of 1 as f of 1 equal to 1. Now if I put x equal to 2, my f of 2 is equal to 2 square is 4. So f of 2 equal to 4. So it's like that. It's like a machine which processes numbers and gives out specific output. So function is basically a special type of relation in which every single input has a specific output. So in order for a relation to become a function, there are two important criteria. So first criteria is every input should have an output. So this is the first criteria. So every input you give, you should get an output. So this is the first criteria. And the next thing is every input has only one output. So what number you give, it should be having only one output, and that's unique for that particular input. So that is the second one. First one is every single input should be having an output. So this is basically criteria for a relation to become function. So let us try to understand functions using this particular example. The textbook I'll be using here is Ncert textbook of 11th standard. I'll put the textbook link in the description. You can go and download it for free. So here I have, let n be the set of all natural numbers and r, so the relation r be defined on n such that r equal to set of all x comma y such that y equal to 2x, where x comma y belongs to natural numbers. We are supposed to find the domain, range, and codomain of R. Is this relation a function? So let us try to find the relation first. So our relation is given as set of all x comma y such that y equal to 2x and x comma y belongs to natural numbers. So basically our y is 2 times x. So if you want to write this in Druser form, it's going to look something like this. So our natural number starts with 1. So if I put 1, so x equal to 1, y becomes 2. So comma 2. If I put x equal to 2, my y becomes 4. If I put x equal to 3, my y becomes 6. So on. So if I put 4, it becomes 8. And then if I put 5, it becomes 10. So on. So this is my relation. Let us try to represent this relation in arrow diagram. So this is our first set n, and this is our second set n. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, so on. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. So let us try to check whether this relation is a function or not. So first goes with, so 1 goes with 2, 2 goes with 4, 3 goes with 6, 4 goes with 8, 5 goes with 10, and so on. So as I told you before, in order for a relation to become a function, every single input should be having an output. So 1 has an output, 2 has an output, 3 has an output, uh, even 6 has an output, so 12 I didn't write. So we can still extend and go on. So every single input has a specific output. And also every single input has one and only one output. So there is no two outputs for one input. So from this I can say this following a relation is a function. So yes, it is a function. Yes, it is a function. And then they're asking, we have supposed to find the domain, codomain, and range. So as I told you, domain is all the inputs which you can give. So what are all the possible inputs? 1, 2, 3, 4, 5, 6. Every single natural number could be taken as domain. So our input or domain is set of all natural numbers. Our range is, you can see our range is 2, 4, 6, 8, 10, so on. So set of all even natural numbers. So set of all even natural numbers is our range, and our codomain as I told you, it's the second set always. So codomain is set of all natural numbers. So this is the answer for the 10th one. So the next thing is the function from a, so function f from a to b is denoted by, so this is how we denote this thing. So we call this as function from a to b. So this is how this is denoted as. And the next one is a function which has either r or one of its subset as its range. It is called a real valued function. So basically, so let us try to understand this using an example. So this is our function f of x, this is our domain which is input, and this is our range, isn't it? So this is our domain and this is our range. So if the range, so what output you get, if the output is either R or one of its subset of R, we can call that as real valued function. So the next one is, if domain and range both is R or the subset of R, then it is called real function. So in this case, only the range was R or subset of R, whereas in this case both domain and range is R or subset of R. So if both domain and range is a real number or the subset of a real number, we can call it as a real function. So this was the note which you need to notice. Now let us try to solve the example 12. So let n be the set of all natural numbers. Define a real valued function f from n to n by f of x equal to 2x plus 1. So you're supposed to use this and complete this table. So first we have x equal to 1. So our input is x equal to 1. For that, for what function? F of x equal to 2x plus 1. So put x equal to 1 in here. So 2 into 1 plus 1. So 2 plus 1, which is 3. So answer for the first input is 3. So if you give x equal to 1, you'll get your output as 3. So next one is x equal to 2. So put x equal to 2. So this becomes 2. So 2 2s are 4. 4 plus 1, 5. So put x equal to, so this is 5. So x equal to 3. F of 3 equal to 2 into 3 plus 1. So 6 plus 1, 7. 7. In the exact same way, try to solve the rest of the problems. So answer for this is going to be 9. This is going to be 11. This is going to be 13. And the answer for the last one is going to be 15. So this was all about the example. Now let us try to understand some specific functions and their graphs. Some functions and their graphs. Now these functions are used widely across the relations and functions and across different fields in mathematics. So the first one is identity function. So identity function is define function from real number to real number for x belongs to R. So x belongs to real numbers. Y equal to f of x equal to x. So this is our function, and this function is called identity function. Now the domain of this function is R, whereas range is also R, which is, so R stands for real numbers, which is all possible numbers. So if you want to represent this function in the form of graph, it's going to look something like this. So this is our x-axis, this is our y-axis, this is our x dash, and this below is our y dash. So this is our origin, 1 2 3. So just if you want to find a graph and you don't know how to do, just go to the function. So our function is y equal to f of x equal to x. So it's basically y equal to x. So for every value of y or every value of x, it's gonna be equal to y. So suppose if I put x equal to 1, my y is also gonna be equal to 1, because y and x basically are equal. If I put x equal to 2, my y is also going to be equal to 2. If I put x equal to 3, y is also going to be 3. So if I represent this on the graph, so x1 y1, so this is 1 comma 1, and this is 2 comma 2 and 3 comma 3. In the exact same way, if I put x equal to minus 1, my y is going to be minus 1. So one more point is going to be somewhere here. If I join this, I'm going to get a straight line, so which is passed through the origin. Straight line. So if you draw in the graph, it's going to be a bit accurate, but in the board it's a bit messy. But if you draw in the graph, you're going to get a straight line passing through the origin, making an angle of 45 degree with the x-axis. So this is our identity function. So where y equal to f of x equal to x. Now if you want to find the domain and range, how are we going to find the domain and range? But not, because normally we can't remember everything. Domain r, range r. How are we going to remember everything? So in order to remember this, you're just going to go to the function. So your function is y equal to f of x equal to x. So what are all the possible inputs which you can give here? You can basically put any number on the number line. You can put any number, which means all real numbers could be taken as input here. So our domain, as I told you before, input is R. Now if you put your input as x, so for every x, your y is also going to be exactly equal. So if your domain is x, your range is also going, so if your domain is R, your range is also going to be R, because basically y is equal to x. For every y, you're going to get the same value of x. So input is equal to output. So domain is equal to R, range is equal to R. So this was identity function. The next, move on to the next function. So the next type of function is constant function. So this function is defined as define function from R to R for x belongs to real numbers. We define y equal to f of x equal to c, where c is a constant number. Now the domain and range we're going to find. So let us try to represent this in the form in the graph. So we have the graph again. So this is the x-axis, y-axis 1 2 3. So we guys already know that if we have y equal to constant, the equation y equal to constant, the graph is going to look something like a line parallel to x-axis. So this is our line. So this line is equal to y equal to constant. Now here, the point where this parallel line meets the y-axis is basically at the point C. So here it's meeting at 2, so we can say y equal to 2. So this line where it meets the y-axis is basically at the point C. So our C equal to 2. So that's why y equal to 2. So this is the example of a constant function. That's why we call it as constant function, because it is basically constant. Now, what are the possible inputs which you can give here? You can give all the inputs, and for every single inputs, you're going to get your output every single time as that constant number. So your input is, or domain is going to be all real numbers, whereas the range, which is the output you can get, so the output is every single time the constant number, so which is C. So this was about constant function. Now the next type of function is polynomial function. So this is defined as, so define function from R to R for every x belongs to real numbers. We have y equal to f of x equal to a0 x bar 0 plus a1 x bar 1, a2 x bar 2 plus a3 x bar 3, so on, an x power n. I think you can see a pattern here. So the powers and the subscript is both the same number. So a0 x0, and then it constantly increases all the way up to n. Now your n is all non-negative integers, which is basically starting from 0 1 2 3 4 5 6 7 8 9 10. So all those kind of numbers. So those are your n. And next your a1 a2, so these coefficients of x. So coefficient of x is basically all real numbers. So keep this in mind. Your powers of x can only be non-negative integers. Like for example, 0 1 2 3, they can only be these kind of numbers. If they are some fraction, which means they're not valid, as a polynomial function. They should always be, the power should always be either 0 1 2 3 4 5 6 all the way up to plus infinity. It should always be a non-negative integers, whereas this number, the coefficient could be any number, it could be any real number. So the domain and range of this function, it changes from power to power. So for example, you have, if I put n equal to 2, if I put n equal to 2, this function becomes something like this. So f of x a 1 x power 1 a2 x power 2. So this is a quadratic equation. So for quadratic equation, the graph is going to be look something like this. So it's a parabola. I can't exactly say what kind of parabola it is, upward or downward. So based on the criteria of what a value is, what a2 value is, the graph changes, and accordingly the domain and range, they keep on changing. So based on the question, based on the criteria, the domain and range adjusts itself. So let us try to solve an example on polynomial function to understand it properly. So the problem is, the example 13, define function from R to R by y equal to f of x equal to x square, where x belongs to real numbers. We're supposed to complete this table and find the domain and range of this particular function, which is y equal to f of x equal to x square. So we have this table. So x, they have given all the possible inputs, and we're supposed to find the outputs. So our function is f of x equal to x square. So f of x equal to x square. So first value is 4. So put f of 4, so f of minus 4, my bad. Minus 4 whole square is 16. So this is 16. So we basically have to square the number and write it over here. So that's basically what the function tells. So next is minus 3. So minus 3 whole square, which is 9. So this is 9. Minus 2 whole square, 4. Minus 1 whole square, 1. 0 square, 0. 1 square, 1. 2 square, 4. 9. 16. Now in order to find domain and range, one of the best ways of finding domain and range is using graphs. So plot this whole x and y in the form of graph, and I'm gonna explain you how you can find domain and range using that. So we have, so 1 2 3 minus 20. So this is our y dash. So our first point is minus 4 comma 16. So minus 4 comma 16 somewhere over here. Minus 3 comma 9. So minus 3 comma 9 somewhere over here. Minus 2 comma 4. Minus 2 comma 4 somewhere over here. Minus 1 comma 1 somewhere over here. So if you plot this, so 0 comma 0 0, 1 comma 1 here, 2 plus 2 comma 4 here, 3 comma 9 3 comma 9 3 comma 9, 4 comma 16. So if you don't know how to plot a graph, you're in a wrong video. So if you join all these points, you're gonna get this parabola. So basically this the graph of this particular function is a parabola. Now based on this we can find the function. So it's basically extends all the way up to infinity. Now what are all the values which which covers in the x-axis? So we cover basically all the numbers. We can extend this and still you can find some value in the y. So from this I can say all the values on the number line is my domain. So x is your domain, so always remember x signifies your domain and y signifies your range. So all the possible values of x, you'll get possible values of y. So I can take every single value and put it in this function. So from this I can say the domain of this particular function is, so domain of this particular function, domain equal to set of all real numbers. Set of all real numbers, because I can put any real value in this function and it's still going to produce a specific output for me. So that is our domain, and our range is our output. So our output is signified by this y-axis, right? So you can see the values start from 0 and goes all the way to plus infinity. So it starts from 0, goes all the way to plus infinity. So I can say from this range is 0 comma infinity. So this is our answer. So this is our domain and this is our range. Now let's move on to the next problem. So the next problem is draw the graph function from R to R defined by f of x equal to x cube, where x belongs to real number. So let's draw the graph, and you guys probably know the best way of drawing graph is putting the table as we did before. So we're gonna do that. So x y f of x equal to x cube. So we're gonna take some random values of x, like 0, 1, 2, and here we're gonna take -1, -2. We're gonna take till -3. Okay, anyway, until here +3, and we are supposed to find the possible values of x, possible values of I for every possible values of x. So if x equal to -3, your y is going to be f of -3 or -3 cube, which is -27. So the answer for this is -27, and y equal to f of -2. For this it's going to be -2 whole cube, so -8. For this is -8, and this is -1, 0, 1, 8, 27. So this is our possible values. Let us try to plot the graph. So we have our x-axis -1, -2, -3, so -30. So now 0 comma 0, so this is our first point. 1 comma 1, so somewhere over here. 2 comma 8, so 2 comma 8, 8 is going to be somewhere over here. And 3 comma 27, 3 comma 27, 27 is somewhere over here, not somewhere over in the middle. Okay, next one is -1 comma -1 comma -1, so it's going to be somewhere here. And next -2 comma 8, -2 comma 8 somewhere over here. -3 comma 27. Now you guys use proper graphing, but I do it on the board, it doesn't look much accurate. But if you do it on the graph sheet, it looks beautiful. So if you want to refer how this looks, just refer the Ncert textbook, page number 41, and then -3 comma 27, -27. So this is our third point. So if you join all these points, it's gonna look something like this. So they just ask us to draw the graph, but we're gonna find the domain and range anyway. So these were the examples of polynomial function, in case you didn't know. So we saw these are polynomials, right? And the examples of these are polynomials. So this is a polynomial function. So we have that graph. So domain, how are we going to find the domain? So domain is all the possible values in the x-axis. So what possible values of x-axis can we take in this? We can take every single one. So I can say domain is all real numbers. Now range. Now let's see where this curve goes in the y-axis. So you can find values of y in every point on the y-axis, even down below also. So from this I can say range is also set of all real numbers. So this was how you solve this example. Now let us move on to the next function, which is rational function. So the next function is rational function. So rational function are the type of function which is in the form of f of x by g of x, where f of x and g of x are polynomial functions, and g of x is not equal to 0. Now x is defined based on the domain, so this changes from condition to condition. So just forget about this for now. This changes from question to question, so that's why it is given as x defined in a domain. So it is defined in the question normally. So if you want to remember this, you can remember using the definition of rational numbers. So what is rational numbers? Numbers which could be expressed in the form of p by q, where p and q are integers and q should not be equal to 0. Why q is not equal to 0? Because if q becomes 0, what happens? P by 0 is infinity, which is not defined. So we have to take all those kind of numbers. So that's why we define this as not equal to 0. In the exact same way, we define a rational function. So f of x by g of x, where f of x and g of x are polynomial functions, and g of x is not equal to 0. So this was rational function. Now let's try to understand this using an example. Example 15. So function defined from r to r minus 0 to r. I'm going to tell you why r minus 0. Defined by f of x equal to 1 by x, where x belongs to r minus 0. We're supposed to find domain range, and we are supposed to complete this table. So let's first complete this table. So f of minus 2. So f of x equal to 1 by x. So if I put f of minus 2, so 1 by minus 2 is gonna become minus 0.5. So in the exact same way, if you try to solve the rest of the things, you're gonna get this as 0.67. This is minus 1, and this is I think minus 2. This is 4. This is 2, 1. This is again 0.67, and this is 0.5. Now if you represent this in the graph, it's gonna come something like this. So this is our x-axis, this is our y-axis. It's gonna look something like this. So in this side, it's gonna look something like this. So these are y, so x dash, and this is our y dash. So from this graph, you can observe the domain is everything apart from 0, because if you put 0, the y is going to turn to infinity. So our domain is r minus 0. Why? Because if you put x equal to 0, if I put x equal to 0 here, the whole thing is going to turn into infinity. So if I put f of 0, if I do, this becomes 1 by 0, and this becomes infinity, which is not valid. So basically this approaches 0 and y approaches infinity. So that's why that value is not approved. And the next thing is range. We're supposed to find the range. So for range, the range is also the same thing. Why? Because we're never going to obtain the exact value of y. See, if as you get closer to as you put smaller and smaller values of x, the y value is going to become larger and larger. So because of that, the range is also r minus 0. So this was this problem. So let us move on to the next one. So the next type of function, modulus function. So function f r to r defined by f of x equal to mod x. So this is, so we write this 2 bars, which means you read it as mod x for each x belongs to real numbers. So this is how the function is defined. So f of x equal to, so if the number what you're putting is positive, you're going to retain as it is. So if it is less than or so greater than or equal to 0, you're going to retain as it is. And if it is a negative number, we're going to convert into a positive number. So the graph is going to look something like this. So if you put, so whatever the value of positive number you put, you're going to get your positive number back. And if it is a negative number, it's going to convert that into a positive number. For example, suppose you have f of minus 3. If you put mod of minus 3, according to the rule, you just have to convert this into positive and write it like this. Because if x is negative, if x is negative, our x is going to convert it to minus of x. In this case, this is minus of 3, which is plus 3. So this is how the modulus function goes, and the graph looks something like this, which is this. The domain is set of all real numbers, because you can see all real numbers, so all values of x could be taken into consideration. So our domain is r, and the range is the y-axis, as I told you to. So to find the range, you should use y-axis. So y-axis covers everything above the origin. So we can take origin and every single number. So x, so 0, so box bracket near the 0 until infinity. So this is modulus function. So the next type of function is signum function. So this function is defined like this. Function from r to r defined by f of x equal to 1 if x is positive, it's 0 if x is 0, and if it is minus 1 if x is negative. So this looks in the graph something like this. So y x, if you put any positive value, the answer is going to be 1. So I'm going to put this circle here. So this is our value if x is greater than 0, and if it is 0, this is our value, and if it is negative, it's going to be minus 1. So this is plus 1, this is 0, and this is minus 1. At minus 1, you should exclude this point because that corresponds to 0, and this is all our number line, minus 1, minus 2, minus 3. This is our plus 1, plus 2, plus 3. This is our y-axis, and this is our x-axis. So your domain is, you can put all the values of x. So that's why all real numbers should be taken as domain. The range is for any value for any values of x, your output is always going to be 1, 0 or minus 1. It's always going to be 1, 0 or minus 1. That's why the range is 1, 0 and minus 1. So the last type of function is greatest integer function. Now this function is also called as box function. So it is defined as function f r to r defined by f of x equal to box x. So this bracket we write and we call it as box x. We call it as box function, that's why. So greatest integer function or box function. So this assumes the greatest integer less than or equal to x. So let me explain how it works. Suppose if I write f of plus 3.22, so if I put box 3.22, you just have to convert that into the nearest like the integer. Just remove the points and just write the integer, which is 3. So if I write 4.77, if I say f of 4.777, so a box of 4.777, just in the answer remove the points and write it off, so 4. So just assume the greatest integer to this number less than or equal to x. So this is our x, just assume the greatest integer less than or equal to x. Now the domain is going to be a set of all real numbers, whereas the range is your all integers. So this is the graph. If you plot the graph of this, it's going to look something like this. So this was all the different type of functions. Now let us see the different algebras of functions. So the algebra of real function. So first is addition. So f plus g of x is equal to f of x plus g of x. So just assume you're just multiplying these two with this, and then you get this. So it's not literally, but in order to remember this, just assume x is getting multiplied with this and this. So you get like that. So the next thing is subtraction. So f minus g of x is f of x minus g of x. Next is multiplication with a scalar. So suppose you have an alpha where alpha is a real number. So if you multiply alpha with f, so alpha f of x equal to, you can take alpha outside, so alpha into f of x. Next one, multiplication with two functions, f g of x equal to f of x into g of x. So this was the fourth one. Next is quotient or division of two functions. So f by g of x equal to f of x divided by g of x. So yeah, we have to make sure whether that g of x is not equal to 0, because if it becomes 0, it turns into infinity. So these were the different types of algebra of real function. Now let us try to solve few problems on this to have a better understanding. If f of x equal to x square and g of x equal to 2x plus 1, we're supposed to find all these things. So let's find the first one, which is f plus g of x. So use the formula, which is this into this, this into this. So f of x plus g of x. So what is f of x? F of x is x square, g of x is 2x plus 1. So this is the first answer. Next answer is f of f minus x, sorry, f minus g of x. So this is f of x minus g of x. So your f of x is x square, whereas minus g of x is 2x plus 1. So if you multiply this minus inside, so it's gonna become this. Next is f into g of x. So f g of x is basically f of x into g of x. So what is f of x? F of x is x squared, g of x is 2x plus 1. So if you multiply this to both internal things, you're going to get something like this. So 2x cube plus 2x square. So this was the third one. So the last one is f by g of x. So this is basically f of x divided by g of x. So our f of x is x square, our g of x is 2x plus 1. Now we need to make sure that this doesn't become 0. So when does this become 0? So this shouldn't become 0, right? So when does this become 0? When x equal to, so 2x equal to minus 1. So x equal to minus 1 by 2. When the value of x becomes minus half, so this becomes 0 and this turns into infinity. So we need to make sure that the value of x is not equal to, so where x is not equal to minus half. So this is the first one. Now let us try to solve one more example. So if f of x equal to root x, g of x equal to x, we're supposed to find the same thing. So first one is f plus g of x. If you know how to solve this, please try to solve and compare with the solution which I give here. So which is f of x plus g of x. So f of x is root x, g of x is x. Next is f minus g of x. So which is f of x minus g of x. So f of x is root x, g of x is minus x. Next is f into g of x. So f of x into g of x. So f of x is root x, g of x is x. Now if you want to further solve this, you can solve it like this. So x is root x is basically x to the power half and x is 1. So this is power 1. So this equals to 1 half plus 1. This is x power 3 by 2. And the next one is f by g of x, which is f of x divided by g of x. Now our f of x is square root of x and our g of x is x. As I told you before, you need to make sure that the x doesn't become 0. So I'm going to write x not equal to 0. You can further simplify this also. So our root x is basically x to the power half, and this is x to the power 1. So if this goes up, it becomes something like this: x power half into x power minus 1. If you simplify this, x power minus half. So this was all about the chapter of relations and functions. If you learn something new, make sure to subscribe to my YouTube channel and hit that notification bar. This video takes a lot of time to make, a lot of effort. My voice is literally gone now. There was so much it takes so much time and effort to do this. So I would like to so if you learn something new, make sure to hit that subscribe button, and I'll meet you in the next video. Thank you so much for watching.